live. Cool. Guys, let's do a brief review of some things we know about quadratics. These are things you learned in algebra, which was ages ago. Some things that we have talked about in this class, but again, talked about over stupid Zoom meetings, which were hard to follow. And so I thought, you know what, let's start by doing a quick review to remind ourselves of some things we need to know. First off, how many x-intercepts can a quadratic have? There are only 3 possible numbers of x-intercepts for a quadratic. 0, 1, and 2. Those are the only possibilities. So we're mostly right now going to be interested in the 1 or 2. 0 x-intercepts is a different issue. We run into some problems when we try to solve stuff. You guys may remember that when you use the quadratic formula and you get the square root of a negative and you're like, oh my gosh, we can't solve this. That tells you, oh, there aren't any x-intercepts, which is why you can't solve the quadratic formula for that. But we're going to look right now, we're going to look at what happens when we've got 2 x-intercepts. So I'm going to use some notation that you may remember, but I will explain it to you. Here's my 2 x-intercepts, and I'm going to call this one x1, and I'm going to call this one x2. This is called subscript notation, and you guys have probably seen it before. You may or may not remember, but subscript notation, here's where you got to be careful. x2 is not the same as x squared. This is a mathematical operation. Multiply it by itself. This just tells you that this is number 2. So that's a fairly important distinction, and this is usually where people like slip up, is they see x2 and then they square it. It's like, well, they saw a 2 and it was somewhere near the x, and so they just squared. So just remember that that's not a mathematical operation. It's just so that you know that that's the first one and this is the second one. And sometimes we'll put letters, like, you know, later on I'm going to go xv, which is stands for the x value of the vertex. So you can put anything you want down there to distinguish. So the first question I would have is, what do we know about that vertex relative to those 2 x-intercepts? Anybody remember? Anyone want to take a stab at it? What do we know about that vertex compared to those 2 x-intercepts?
It's in the middle.
It's in the middle, exactly. Parabolas have symmetry. We've got symmetry here and here, which means that the vertex has to be exactly halfway between those 2 x values. What's another word for exactly halfway between 2 numbers? Anyone? A word that means exactly halfway between 2 numbers. Who said that? Average. Yeah. If you got 80 on a test and 100 on a test, your average is 90. Why is your average 90? Because 90 is exactly halfway between 80 and 100. So the vertex value, x vertex, has to be halfway between x1 and x2. And the way we calculate that is we just take the average. x1 plus x2 divided by 2. Boom. I know the x value of the vertex. Now, here's the other thing. Since we have symmetry, there must be a line of symmetry. Remember that from geometry? And lines have equations. And vertical lines specifically just have the equation x equals whatever that value is. So if it's 2, the equation of that line would be x equals 2. If it's 7.5, the equation of that line, x equals 7.5. Vertical lines have the equation x equals something. There's no y at all. Because it doesn't matter what y is. You go up and down, y changes, doesn't affect the line. The only thing that matters for that line is that it has some value x, no matter where you are. X, the value never changes. Any questions about that? We comfortable with everything I've written on the board? Does it make sense to you? You probably remember a lot of it as you see it written up. You're like, oh, yeah, I remember that. We talked about that in algebra, Mr. Brannan's or Mr. Guyash's or Mr. Zeger's, depending on which class you took. So, all right. So now, where are we going with this? What do we do next? Let's look at a specific example. Actual numbers instead of just symbols. I know we all love actual numbers. As soon as the numbers appear, it's like, oh, this is easy now. It's got numbers in it. Y equals x minus 2, x plus 4. You to take a second and think, what do I know about x-intercepts? Everything I know about x-intercepts. Make yourself some little notes down, or store it away in your head. And I am going to ask somebody to tell me. This is completely discombobulated. I have to do something about this. But I'm going to ask you, based on pulling somebody's name out of the cup. Let's see. Make sure I got everybody in here. You guys remember this? I showed it to you on the Zoom meeting once, and then I didn't show it to you. But so all your names are on a popsicle stick. But here's the nice thing about this. It's totally random. You know I'm not picking on you. When I call your name, you're not like, Mr. Armory's picking on me. No, it's totally random. I never look. I just pull this out, and I say, Jared, what do you know about x-intercepts? Give us one fact about x-intercepts that you remember.
I mean, I can tell you what they are.
Okay. How do you know what they are?
Well, I don't know how it works, but all I know is that you take like one side, like x minus 2, and then you make y equals 0.
Boom. Stop right there. X-intercepts, y equals 0. That's a really, really good thing to remember, because that is always true. If I'm on this x-axis, then y is equal to 0. So I can take any equation with an x and a y, and if I make y equal to 0, all I got to do is solve for x. And I know the x-intercepts. It's easy to say, not always easy to do, but if it's linear or quadratic, we know how to do that. So if I want y equal to 0, then x minus 2 must be equal to 0, or x plus plus 4 must be equal to 0. Agreed? If one of those parentheses is equal to 0, when I multiply them together, the whole thing becomes 0. This is why we factor quadratics, because then it's really easy to find the x-intercepts. So I've got x-intercepts at x equals 2 and x equals -4. And then now I want to find the vertex. So here we go. Going back over here, I want to average those two values. So I add them together and divide by 2. 2 plus -4 divided by 2. 2 plus -4 is -2 divided by 2 is -1. I know that the vertex must be at -1 comma something. Next question for you. Think about it in your head, jot down some notes if you need them to remember. Now that I know that x is -1, how am I going to find the y value? So give that a little bit of thought. All right, let's see what we got. Eliana, now that I know that x is -1, how can I use that to find the y value? Do I have some sort of relationship between x and y up here on the board? Where? Well, y, no, you're right. You're right. Y equals 0 will tell us the x-intercepts. But what's the other relationship between x and y? This is just a if y equals 0, then x is the x-intercept. What's my other relationship between x and y, Eliana? Go all the way to the top of the board. What do you see? Are there x's in it?
Yeah.
Boom. That's it. That's what an equation is. An equation is the relationship between the variables. Y equals x minus 2 times x plus 4. So if I know x, can I calculate y? Yeah. I'm going to plug them in. So let's find the y value. Y equals -1 minus 2 times -1 plus 4. Well, that's -3, and this is +3. And so this is -9, which means that the vertex is at -1, -9. And now I can graph this parabola. So let's make ourselves some graphing room. And let's take a little side trip and talk about quick graphing quadratics or parabolas. Because I'm going to ask you to do this on a regular basis. Quick graph means you don't need a calculator. All you need is some basic information. So let's look at x squared. And I'm going to make a table of values, -3, -2, -1, 0, 1, 2, 3. You know, the standard table of values that they always told you to make in middle school when they were teaching you how to graph, go from -3 to +3. And I know that -3 squared is 9, and I know that -2 squared is 4, and I know that -1 squared is 1, and that 0 squared is 0, and that 1 squared is 1, and 2 squared is 4, and 3 squared is 9. Are we all in agreement on those? Everybody comfortable that a negative times a negative gives us a positive so that we don't accidentally think that that'll be -9, -4, -1? So here's how quick graph works. There's my vertex, 0, 0, because it goes up from there. And here's what I notice. 1 squared is 1, but so is -1 squared. So my next set of points is going to be here and here. I don't have to look at my calculator, because I know that starting at the vertex, 1 squared is 1, so I just go out and up. My next set of points, 2 and -2. Well, I know those are both 4. So I know that if I go out 2, I can just go up 4, which means that I could put a point here and here. Hey, look, I'm done. I've graphed my parabola. I could do the 9s and the 3s, but I didn't make my graph tall enough. So I'm not gonna. I'm just gonna say, oh, look, I've got a parabola. Guys, this is the pattern for a quick graph. And here's what I'm going to be telling you or asking you to do on occasion. I know you probably don't have one today necessarily, but a highlighter. I'm going to occasionally say, I want you to highlight that. And I want you to take out a highlighter, and I will get one out for you if you don't have one right now. And put a box or put a highlighted box around that. Let me loan out some highlight. Who needs a highlighter? We'll start here. Highlight, pass it back. Let me grab some more. There you go. Pass it back. Pass it back. And then make sure I get those back, because, you know, I need my highlighters. Did you get it, Luis? Eliana, you already had one. You need one? Catch. When you were flipping through your notebook, when you were doing homework assignments, when you were doing your asynchronous work, keep in mind that I'm having you highlight important ideas. So when you get to the point where you're stuck on something, look at it and say, I wonder if there's something in my notebook that's been highlighted. And if you flip through, I bet a lot of the time you're gonna be like, oh my gosh, there it is. Oh yeah, he said quick graph. Boom, there's a picture of how I do a quick graph. So let's now do a quick graph of this new quadratic. And here's what this looks like. My vertex is at -1, -9. So I'm going to draw my graph over here. So there's my vertex. Now, what happens when I go out 1? In both directions, I go up 1. So I can put a dot here, and I can put a dot here. That's at -2. And this is -8. And then what happens when I go from the vertex out 2? How much do I go up? No, remember 2 squared is 4. So when I go out 2 from the vertex to +1, I'm going to go 1, 2, 3, 4. I go to right there, -8, -7, -6. Nope, 6, -5. And same thing in this direction, because symmetry. What happens when I go out 3? How much do I go up? 9. Yeah. So now I'm over here at 2, and I'm going up 9. And I'm over here at -4, and I'm going up 9. Oh, hey, look. My x-intercepts. How convenient. And I've got enough to draw myself a beautiful parabola. When you see the word quick graph, that's what I want you thinking about. I don't want you thinking, oh, I'll grab my calculator and I'll type the equation into the calculator and then I'll look at the table and then I'll just start plotting points randomly. Where's the vertex? 1, 4, 9, boom, you're done. If you know where the vertex is, you can quick graph a parabola in about 30 seconds. Maybe a minute if you really take your time. Pretty handy. All right? Any questions? Cool. All right, let's look at another equation. Here we go. New equation. Hey, Mr. Harmony, you didn't erase the whole equation. I know, because I'm going to write the new equation like that. Also known as y equals x minus 2 squared. You guys ready for another aside? I'm going to erase this graph because we don't need it right now. Here's another aside for you. I'm going to do this one in red. Things I will never, ever do. This isn't life advice. This is math advice. X minus 2 squared. X squared plus 4. Are not the same thing. And this is a mistake I see over and over and over again. And here's why. Here's why people make this mistake. Do we agree that 2 times x minus 2 is 2x minus 4? Because we distribute the 2. I'm going to take a green pen and put a happy face next to that. And here's why I think people do this. Oh, I distribute the 2. And so I square the x and I square the 2, or the negative 2. But of course, that's not how we do that, is it? How do we multiply x minus 2 squared? Well, x minus 2 squared is x minus 2 times x minus 2. X times x, negative 2 times x, negative 2 times x, negative 2 times negative 2, x squared minus 4x plus 4. Huge difference, isn't it? Look at that. Huge, huge difference. So I think the thing to try to remember, put that in the back of your brain somewhere, we never distribute squares. Because squared means multiply by itself. It doesn't mean square all the bits. Okay? Still got that highlighter kicking around? That's a good one to highlight. Some of you already have. You just highlight, pass it back to the next person. I'll get them back to you at the end. Or back from you at the end. All right, so let's go back and let's look at this. What are the x-intercepts of that equation? First thing we remember is that y is equal to 0, which means that x must be equal to, guys, I want you to take about 30 seconds and think about that. What values of x will make that thing equal to 0? what values of x will make this thing equal 0? Diana? Is there any other value of x that'll make it equal to 0? So if I plug in 0 here, will I get y equals 0? No, I won't, will I? So no, there isn't. There's only one value of x. Well, that's weird. Oh, wait. This one only has one x-intercept, which means that this one has a vertex right there on the x-axis. One x-intercept. Therefore, vertex on x-axis. Let's do a quick graph. Ready? There's 1. There's 3. I'm going over 1. How much do I go up? Anybody? How much did I go up? Over 1, up? 1. I go over 2. How much do I go up? 4. Hey, look, I'm done. There's a beautiful graph of y equals x minus 2 squared. Your turn. Y equals x minus 3 squared. I want you to find the vertex. No calculators. Just think about what we've been doing and make a quick graph. Y equals x minus 3 squared. Where's the vertex? Draw a quick graph. About 30 more seconds. Let's see what we got. Eduardo, where's the vertex?
Okay, I'm gonna be honest. The square thing that you did, I always get stuck on that, and Luis threw me the highlighter and didn't get how to write it down.
Okay.
So I don't know.
Okay. So what if I were to, Eduardo, write this as y equals x minus 3 times x minus 3? Would that make a difference?
It would make it easier to solve it a different way.
Could you tell me what values of x make that equal to 0?
3,
So where's the vertex?
3.
That's it. The vertex is at x equals 3 and y equals 0. Because it only has one x-intercept, we can't average the two numbers if there's only one number. Or another way to look at it would be to say, well, there are two of them. There's a 3 and then there's a 3. But if I average 3 and 3, what do I get? 3. So my vertex is at 3. Oh, cool. So let's draw a quick graph. Here we go. Since I'm going up, I don't need to make so much axis in the down direction. 1, 2, 3. There it is. There's my vertex. Over 1, up how much? 1. Over 2, up how much? 4. Oh, hey, look. There's a beautiful graph of a parabola. Getting the hang of this? All right. We got one more. Let's write y equals x minus 3 squared on this. By the way, to circle back around to Eduardo's original answer, I'm okay with that answer. I am 100% okay with not sure. That's an okay answer. Eliana's earlier. I don't know. And what I will try to do is I will try to elicit something from you that gets us going in the right direction. So don't feel bad. I don't ever want you to feel bad because you don't know the answer or because you get the wrong answer, because we'll take that and we'll just say, okay, well, what about? Just like we did here, where we said, well, what if I rewrote it? And boom, Eduardo immediately was, oh yeah, that makes sense. And over here, when I said to Eliana, well, what's the equation right there at the top? Oh yeah, it's y equals x minus 2. Those are good answers, as long as we eventually get somewhere and we keep trying. So yeah, there you go. Just keep that in mind. You don't have to be embarrassed because you didn't know the answer or you make a mistake. I will tell you right now, I've already made like 4 mistakes this week. Some of them I caught myself, and some of them students said, Mr. Harmony, why did you write that? I have no idea why I wrote that. Let's change it. So it happens. All right, your turn. Number 2. Where's the vertex? Draw a quick graph. Go. axis, you know where that is, because otherwise, you know, maybe your scale is by tens. I'm sorry. Uh-oh, going down, or are you going up? Yeah, remember, square is always going to be positive, so it's always going to make it go up. All right, let's see who we got here. Justin, where's the vertex?
-3.
-3, I like it. And since we're at -3, we'll make our graph sort of bigger in this direction. So, over 1, up how much? 1. Good. I hope I'm hearing everybody calling that out, and everybody is saying, "Oh yeah, I knew that. I knew that." Sometimes repetition makes it easier to remember. Over 2, up what?
4.
4. I love it. Big old chime. Everybody shouting it out. Oh my gosh, we are getting good at drawing parabolas, aren't we? Cool. So let's make a little table here. Y equals x plus 3 squared, vertex -3. Y equals x minus 2 squared, vertex +2. Y equals x minus 3 squared, vertex 3. Seeing a pattern there? What if I gave you the equation y equals x minus h squared? Take a second and think about what number would go right here. What number would I put in the parentheses for that vertex for x minus h squared? Everybody had time to think? Need a little more? Let's see what we got. Not here. Can't answer the question. Not here. Can't answer the question. Xander.
Yeah, I don't know. Sure.
Well, where did we get -3, +2, and +3, Xander?
Well, it's like the opposite.
Okay.
So it'd be, I guess it would be like 8.
What do you think? Yeah, absolutely. The only difference is that it's not an actual number. It's a letter that represents a number. Oh my gosh. You mean this is an algebra class? Yeah. For any equation that I give you, all you got to do is take the opposite and boom, you know the vertex. Open your Chromebooks and go to www.desmos.com and click the thing that says, yes, I want a graphing calculator. Guys, let me tell you very quickly on the Chromebooks. I have one Chromebook power plug. I have 0 extension cords, which means that if your Chromebook at this point, although I'm going to probably go buy a couple extension cords, hang on, if your Chromebook runs out of power during class, there's going to be limited options. I would recommend that you throw the power cord into your backpack. I will try to have a couple extension cords within the next few days so that if you do run out of power, we can run an extension cord Or maybe I just have to move you to a desk near a power outlet, but I have a limited number of those. Yeah.
Yeah, so it's restricted.
There's no possible way that Desmos.com
Restricted.
could be restricted. That is so annoying because you are looking for Desoms.
I spelled that right.
And who knows what the heck Desoms.com is? I don't know.
Right. I mean, I saw graphing calculator. That's pretty right.
No worries, no worries. It's all right. These things happen. DESMOS.com. Choose the what? You got it?
Yeah.
All right, good. Now, here's what I want you to do. Top left corner, there's a little place you can enter an equation. Here's the equation I want you to enter. F of x equals parentheses x minus h squared. I want you to type that equation into the top left little bar where it lets you type in equation. Now, when you do that, it is going to give you an option. It is going to say, you want to create a slider for h? And the correct answer is, heck yeah, I totally want a slider for h. F of x equals x minus h squared. Yes, I want to create a slider for h. Now, you can drag the slider back and forth and see what happens to your graph. I'm going to come around and take a look, see if you got it. You don't have, you can just do squared. Oh, you guys know the symbol for squared? It's this little thing right here above the 6. This means to the power. It's right above the 6 on your keyboard. So you don't have to type x minus h times x minus h. It becomes a little bit easier. Little caret, C-A-R-A-T, right above the 6 key. So just right there, yeah, just start typing. That equation I got right there. Here, let me highlight it for you. Here you go. This is the equation I want you to put into Desmos, right there. Boom. Let's see what we got. Nice. Did you slide the, oh, wait, why didn't it graph? Oh, yeah, there it is. Cool. Nice. Cool. Have you slipped the slider back and forth? Isn't that awesome? So exciting. Nice. Nice. Excellent. Excellent. Woo! Isn't that exciting? Cool. So, what does the slider do? What happens when you change h? It slides the whole parabola. Justin, when you slide the slider to the right, making h positive, which direction does the parabola go?
To the right.
To the right. Luis, when you slide the slider to the left, making h negative, which way does the parabola go? Oh my gosh, it's that easy. We call this the horizontal shift. Because it takes the whole parabola and it shifts it horizontally, left and right. Left, right. Guys, I want you to write this down, and I want you to highlight it. My yellow highlighter is, okay, there it goes, now it's working. I want you to highlight that. This is the key idea for today, is that we can horizontally shift a parabola by just changing that value of h and moving it left and right on our graph. And if we know what h is, we know where the vertex is. So for the first couple weeks, I'm not going to give you homework assignments on Wednesday and Thursday. What I am going to do is give you the Wednesday, Thursday, we'll be doing classwork. Monday, Tuesday, you'll be doing an assignment that I give you to take home. What I may do after the first couple of weeks, when we've had a chance to settle in, is give you some homework, but they'll be small homework. I'm not planning on giving you a full-blown homework assignment on Wednesday and Thursday at this point. But what I might do is like have a couple of these problems to send home with you and say, okay, do these for homework, and we'll talk about them as, when we come in on Thursday. Not really 100% sure what this is all going to look like. It has to, we got to shake it out and figure out what works and what doesn't work. So for the next couple of weeks anyway, you don't have to do anything math-wise at home. Come back tomorrow. We're going to continue this discussion tomorrow, right where we left off, and we're going to look at some more transformations. So, okay? Awesome. Thanks, guys. Great job. You can leave the highlighters on the desk, so I'll just come around and collect them. If they're your highlighter, you don't have to leave it on the desk. You can take it with you. You're going to go to homeroom next. Does everybody know where their homeroom classroom is? Who do you have for homeroom? Mr. Lawrence? You're going to go up these stairs, and he's the very first classroom on your left-hand side. Anybody else? You know where you're going? Know where you're going? Everybody knows where they're going for homeroom? Sweet. So if I see you wandering around the hall 10 minutes from now looking lost, I'll say, well, dude, why didn't you just ask me? Awesome. Great, guys. It was great to see you. This was fun. I enjoyed it. I hope you did too. Better than sitting on a Zoom meeting. Yes, I do. So if you go down the hall this way, it's going to be the very last classroom on the left before you get to the commons area.
Okay.
If you see the staff lunchroom, you just passed it.
So I'm not gonna be here maybe just like Thursday
Every week?
Yeah, because my mom has got company Monday, Wednesday, and nobody can pick me up down there.
Okay, and you can't take the bus?
I only have this class in. That's the
Oh,
problem.
okay,
I'm
okay.
gonna get my license.
Yes, that would be awesome. Cool. Okay, well, thanks for letting me know. Do me a favor, so you're not gonna be here tomorrow?
I don't know, I'll ask my dad.
Okay, if you're not, try to watch that live stream.
Yeah.
I don't know if it'll work. Right now, I'm just sort of experimenting, but yeah, try to watch the live stream, because I would love it if you emailed me and said, oh yes, I watched the live stream, it was great, or oh no, I tried to watch it and it wouldn't work, or hey, Mr. Irwin, did you know that this didn't work properly? And so then I can start making it better. That'd be awesome. So, all right, cool. Well, have a good day. Howdy.
How's it going?
Good. Ooh. If you would like Pop-Tarts and some juice, please grab yourself a packet of Pop-Tarts and a juice.
All right, thanks. This
Have
is
a-
homeroom, right?
What's that?
Homeroom, right?
This is homeroom, right? Yes. Apparently we feed you during homeroom. Qualifying Pop-Tarts as food, but yeah. I love Pop-Tarts. I also don't eat sugar or other carbs for the most part.
I've never liked Pop-Tarts or something.
Oh, really? Oh, I love
I
them.
really do.
I mean, especially if you can toast them. They're not as good
That's what you're supposed
untoasted.
to do?
Yeah. Oh, yeah. You're supposed to toast. That's why they're called Pop-Tarts, because they pop out of the toaster. And
Oh, I did not know that. It's just get about a package. Maybe
they're
I'll give it.
so much better when they're toasted, because then they're all warm and the pastry gets all crumbly. And, oh. But no, I don't need any of that stuff anymore. It's just like, oh, man. Oh, look, my screwdriver. This is last week. Oh. I have no idea what we're supposed to do today.
For 30 minutes?
I don't know. Oh, I do know what we're supposed to do today because it would be the same thing that we did. The same thing that we did on Monday, which was we didn't. At some point, they're going to discover that I'm not doing the character strong stuff.
Uh-oh.
And they're going to, hey, Nicole.
Hey.
They're going to come and they're going to yell at me.
Uh-oh.
Oh.
And I'm going to say, oh, I didn't know that was required. Because I hate it. I don't want to do it. I don't want to sit here in this room and talk with you about our feelings.
Yeah, I don't blame you.
Just,
I mean, I feel that.
how do you feel about talking about your feelings? It makes me really uncomfortable.
I like talking about myself.
Oh, I don't want to talk about myself. That's a different, I mean, talking about just, stuff you've done and, but it's all emotional thing. It's like, how does it feel when somebody punches you in the face? It hurts. Okay, end of conversation. Next.
Yeah.
How does it feel when somebody's mean to you? Well, no, it's not a good feeling. Why do we have to talk about it? So yeah, what we did on Monday is we talked about what we did over the weekend, just like we do when we're on Zoom.
Oh, really?
And then we just sort of went off in random directions, and it was way more fun. Hey, Nicole, if you want a Pop-Tarts and a thing of juice, grab one. You can eat them in here, which is amazing. I've never let people eat in my classroom, but now I feel like I don't have a choice because they're giving us food and saying, have your kids eat this. Crumbs everywhere. Really?
Seriously, only two.
Really?
I guess. Like, we only have like 80 people in our home room.
Yeah.
So.
Let's see. Nicole's here. Zach's. Yeah, this
Is
is
there really
it.
only 2 people in this home room?
Yeah, because there's 2 people who aren't coming into school at all.
Mm-hmm.
And then there's 1, 2, 3, 4, 5 in my Monday homeroom.
So it's literally.
Literally the 3 of us. All right. Well, guess what? I'm not gonna do anything. But I need to put some music on.
Figured that there would at least be more people.
Yeah, well, then I realized that we don't have that many. Zoom
True.
apps anyway.
All right. So if we were talking about, okay, so what we're gonna do today is we're gonna divide into 2 groups.
Okay.
And each group is going to, wait, what? Each group should compare their ideas. How are your weekends?
Not bad. Went golfing again. It's way too cold. I don't know why I keep going. I really don't know why. And it rains. It's no, it's fine decision.
The nice thing about going golfing when the weather's not great is that you will then appreciate so much more when the weather gets better. Because you'll be like if you just waited until the weather was great, you might even get up one morning and the weather was just sort of okay, and you'll be like, oh, the weather's really crummy out there. I don't want to go golfing. Whereas compared to
Now, yeah, it's like frosted, frozen.
Did I tell you I went golfing like a year and a half ago with a buddy?
I think so. Yeah.
And by the 14th hole, I could barely carry my stuff and walk. And by the 16th hole, I just wasn't even golfing anymore because I couldn't even swing. I was so tired.
Yeah.
Oh my gosh.
Yeah.
It was amazing. And I had a blast.
Yeah.
I mean, I had a great time. I went to the driving range a couple times after that. It was horrible because can't consistently hit the ball because it's been so many years. And I was like, oh, okay, well, I'll take some lessons. That was last March, so it's gonna go down and take some lessons. And then went that, haven't golfed again.
Yeah, it's hard. A lot of people, I think that's why not a lot of people do it.
Yeah.
Never get into it. Hard.
Well, so I feel like most people would get bored right away.
Yeah, bored, paying money to miss a golf ball, shake it. Yeah.
Well, I will eventually. I will go back. I was just sort of waiting till the point, because I mean, I think everything was closed for the longest time. And then,
Yeah.
so I will go down, but I'm gonna take some lessons, because yeah, I don't want to just like hack my way around,
Yeah.
you know, scoring 180 on a golf course if I hack like 30 yards at a time. If I'm gonna do it, I want a guy to sort of say, hey, you know, this is what you're doing wrong with your swing, and then, okay, great, thanks. And then I'll go off and hopefully get better.
It takes a while. A long time.
And I
A lot of
used to.
patience.
I used to, and I mean, I used to golf, and there's part of the problem too. I discovered this, so a lot of things that I did when I was younger and that I didn't do for years, in your mind, you can still do them. You know, I know in my mind exactly what I need to do in order to hit the golf ball, but it didn't ever quite work. Skating's the same way, I used to play hockey.
Really?
I haven't skated in 30 years, 25 years. And I went down to the skating rink about 4 or 5 years ago. I know how to skate.
Yeah.
I can skate back. I can do backwards crossovers. I can spin around. I can do all the things you got to do in hockey. And I got out there and I wobbled my way around like some 3-year-old. And then my ankles hurt, and I was just like, what?
Yeah.
This is awful. What the heck? I can't play hockey like this. I didn't do that much either. I mean, again, you know, I live in Blaine. Have to drive all the way to Bellingham to go skating, and then they've got weird hours for skating. And I mean, when I grew up, well, still in Canada, there's skating rinks everywhere.
Yeah.
There's like 4 of them in White Rock.
Really?
Yeah, the whole Whatcom County has 1 skating rink, and White Rock alone has 4 skating rinks. So my thought was that I might just start popping up to White Rock once you cross the border.
Yeah, as you say. Yeah.
But yeah, just because it's like 5 minutes to the skating rink if I go through the border versus half an hour if I drive.
True. Yeah, so there's that and feel closer.
Yeah. So Nicole, what did you do on the weekend?
I started watching this series called The Masked Singer. Pretty interesting, a lot of different
Is
singers.
it like COVID masks or like big gorilla masks?
There's a butterfly, like in a full butterfly costume, a full bulldog costume, a tree costume.
Okay, so they're like going out of the way that you have no idea who's underneath there, but all you're
You have
hearing is
no
them
idea,
singing.
you have to guess, you have to just guess off their voice.
Oh, interesting. Interesting.
Very entertaining to watch.
It's funny because I never watch reality shows ever. But I understand why people do watch them, because you get sucked in so easily. I went to visit my brother like 3 years ago, and they watch, what's the show they watch? We're watching it now, 3 or 4 years ago. Would American Idol have been big then, or maybe it was just different?
Maybe. Yeah.
Anyway, it was something like that. And I had no interest at all, but what did my brother and his wife do? Every, you know, they sit down and they watch it. So what do? I could just say, well, I'm not going to watch TV with you, so I watch it. Well, by the end of staying there for 2 weeks, visiting them, I'd seen 3 episodes. I can't wait to watch the 4th episode.
Oh my God, you got hooked.
I got sucked in. Well, what did I do? Is I went home and I said, no, I can escape the thing. And I got over it very quickly. But yeah, it's like, oh yeah, so into it. It's like watching soap operas. I remember in college, the girls, so I lived in a dorm, and there were 1, 2, 3, 4 rooms with a lounge and a bathroom in like these little clusters. And then on each floor of the dorm, there was, I think, 10 of these little clusters. And it'd be about half and half boys and girls, but you had your own, the boys and girls weren't living in the same cluster. So you had your own bathroom, your own lab. Well, what do you want to do when you're an 18-year-old boy? You want to hang out with the girls. Well, what were the girls doing? They were watching a soap opera at 3 o'clock. You guys should come down. I don't really want to watch a soap opera, but all the girls are going to be there. So you go watch soap operas because you got to hang out with the girls if you watch soap